Now I'm going to solve one more question for complex number Olympiad questions. Here Z1, Z2, Z3, they are given complex number, and the modulus of them, they are all equal to each other, and that's equal to R, and this is greater than 0. R is a number here, and it's written here that Z1 plus Z2 plus Z2 times Z3 plus Z3 times Z1 all over Z1 plus Z2 plus Z3 module is equal to R again. Here Z1 plus Z2 plus Z3 cannot be equal to 0 because it will be undefined. So how to solve this question? What is the trick for the question? Let me explain here. First, let's define a complex number like W, and W is equal to Z1 plus Z1 times Z2 and plus Z2 times Z3 plus Z3 times Z1 all over Z1 times Z1 plus Z2 plus Z3. It's going to be. Now I'm going to multiply this one by Z1 module times Z2 conjugate times, not module, sorry, Z1 conjugate times Z2 conjugate times Z3 conjugate all over Z1 conjugate times Z2 conjugate times Z3 conjugate. Why I'm multiplying with this one? Because if I multiply these, I'm going to get Z1 times Z1 conjugate. Also, I'm going to return to this expression, which means if Z1 times, here, let me write with different color that one. Here, if Z1 module is equal to R, it means that Z1 times Z1 conjugate, it's equal to R squared. This is the relation between Z1 and Z1 module and R. Or if it is Z2 module is equal to R, it implies that Z2 times Z2 module square is Z2 conjugate is equal to R square. It's going to be. Okay, for the Z3, it's equal to R, which means that Z3 times Z3 conjugate is equal to R square. It's going to be. Let's multiply these expressions here, and it's going to be like W is equal to, let me return to main color, W is equal to Z1 times Z2 times Z1 conjugate times Z2 conjugate times Z3 conjugate plus Z1 times Z2 times Z3 times Z1 conjugate times Z2 conjugate times Z3 conjugate. It's going to be, and plus Z3 times Z1 times Z1 conjugate times Z2 conjugate times Z3 conjugate. It's going to be all over. Now Z1 times Z1 conjugate times Z2 conjugate times Z3 conjugate plus Z2 times Z1 conjugate times Z2 conjugate times Z3 conjugate. I'm applying distribution law, as you understood. And the last one is Z3 times Z1 conjugate times Z2 conjugate times Z3 conjugate. It's going to be. Okay, if I rearrange numerator and denominator, W it's going to be equal to Z1 times Z1 conjugate times Z2 times Z2 conjugate times Z3 conjugate plus here it's equal to, now this is going to be equal to here Z1 times Z2 times Z2 conjugate times yes Z3 times Z3 conjugate times Z1 conjugate, and the last one it's going to be equal to Z3 times Z3 conjugate, Z1 times Z1 conjugate, and the last one it's going to be Z1, Z3, Z1 I used, and Z2 conjugate. Yes, this is the thing. Okay, all over Z1 times Z1 conjugate times Z2 times Z3 conjugates. I forget here, plus Z2 times Z2 conjugate times Z1 conjugate times Z3 conjugate, and the last one is Z3 times Z3 conjugate times Z1 times Z2. It's going to be conjugates again. Okay, what is the here? If you remember at the beginning I said these are equal to 1, that's why these are equal to r squared. So this is going to be r squared, and this is going to be r squared, and r squared times r squared, it's going to be equal to r to the power of 4. So this is r to the power of 4, this is r to the power of 4, this is r to the power of 4. It's going to, then here it's going to be equal to w. I'm going to return to same color. W is equal to r to the power of 4 times Z3 module plus, Z3 conjugate, r to the power of 4 times Z1 conjugate plus r to the power of 4 again, I'm sorry, r to the power of 4 times Z2 conjugate, all over. Here these are normally r squares. These are r square, and I'm going to leave these are like this. Then it's going to be like here. This is going to be equal to. Firstly, I'm going to write this one more time with different color. I don't want you to confuse the things while you're writing. Okay, then this is going to be r squared times Z2 conjugate times Z3 conjugate plus r squared times Z1 conjugate times Z3 conjugate plus r squared times, here it's going to be equal to what it is again, r squared times Z1 conjugate times Z2 conjugate. Yes, okay, I saw this one. Now all the numerators has r to the power of 4, all the denominators has r to the power of 2. If I simplify these expressions, w is equal to r to the power of 4 parentheses Z3 conjugate plus Z1 conjugate plus Z2 conjugate over r square times Z1, Z2, Z3 conjugates plus Z1, Z3 conjugate, Z1 conjugate times Z3 conjugate, of course, and the last one Z1 conjugate times Z2 conjugate. Okay, then here I'm going to simplify r to the power of 4 by r to the power of 2, and it's going to be like here this one and this one. If you simplify, this is going to be r to the power of 2, and these all expressions, there is an addition between them. If you remember, if you have Z1 power Z and Z1 and Z2 conjugate can be written as Z1 conjugate plus Z2 conjugate. So you may distribute the conjugate operation here, or if I write this one this side, it's going to be more better. Here it is. To this side I'm going to write. Here then I'm going to use this property. Here w is equal to r squared times I'm going to rearrange also them, Z1 conjugate, Z1 plus Z2 plus Z3 conjugate, all over Z1 times Z2 plus Z3 here it's going to be equal to Z2 times Z3 plus Z1 times Z3 all conjugate. Okay, what is this expression here? This is the last part. Now this is W is equal to R squared times Z1 plus Z2 plus Z3 all over Z1 times Z2 plus Z2 times Z3 plus Z1 times Z3 times Z3 conjugate. Okay, now this expression, when I check this expression, I recognize that this expression, the last one here, and what I have written here, this expression and this expression, they are multiplicative inverse of each other. If you remember this property, if you have A over B, A over B, then this is equal to B over A to the power of minus 1, or here it's going to be equal to, if this is W, then it's also at the same time it's equal to 1 over W to the power of minus 1. That's why this, when they change their places, it means that they are multiplicative inverse of each other, and this can be written like that also. Here, this W is equal to, I'm going to write this part again. Yes, this W is equal to, W is equal to R squared times 1 over W conjugate, which is equal to, I don't have space, that's why I'm going to continue to the right side. W is equal to R squared times 1 over W conjugate, which means that W times W conjugate is equal to R squared. If W is complex number, W conjugate is the conjugate of it, and if it's equal to R squared, which means that modulo of W is equal to R, it's going to be. This was the rule, if you remember, and I proved that W, what is chosen, if I multiply with this number, then W module is equal to R, and I found this one.